Enabling the 5G ecosystem with data center and optical network innovation was the title of a presentation given today at the ECOC Market Focus by Markus Grun of Keysight. Markus, thanks for joining us. Give us some of the highlights of what you were talking about today.
Yeah, I was talking about how the network topology is evolving and how what's 5G at the end means to the whole topology. So we're starting at the access side, where we'll see that the edge cloud will come to the whole topology as the industry will need this edge cloud system to improve their productivity, and so we will have a new part in here at the access side. And then moving forward, so we should avoid bottlenecks into the whole topology. So there is a transport network that have to add up, bring silicon photonics into place, because all the power consumption of the will increase for the devices. So how to get this down at the end is more to get the optic more closer to the ASIC to avoid that much copper connection as possible. And nevertheless, at the end, it's about electrical communication bus systems on the server side, right? To overcome the huge traffic problems. So they have to be increased, and there we have small margins, but at the end the trend for this bus system is already there and set. So the question is the optical network ready, and is the silicon photonic right in place when the 5G is deployed?
Tell us a bit more. You mentioned earlier about the edge cloud. Tell us a bit more about the role that plays.
Yeah, it's really interesting, because if you see the German broadband network for 5G, this is so split up that there is a specific segment that is secured for industry communication in 5G. So there will be huge demand for the industry to having 5G networks. And then on top of this campus networks, they will have edge cloud systems. And this edge clouds, they are using their own algorithms to react on sensor data they will get, to analyze them and really giving the answer to the actor, right? So that the whole manufacturing line, for example, is working in time with low latency and really real huge reliability. And this is one of the topics where there's a triangle of areas for 5G. One is just increase the data. The other one is having massive IoT, more devices in a small condensed area. And the other one is really the reliability and the security of the whole network to have healthcare applications, for example, that are plenty good secured, right?
You also mentioned in your first question a little bit, you mentioned silicon photonics. That's been a big talking point for 2 or 3 years here. How does that fit into the scheme of things?
Yeah, I think this is, as mentioned before, you have to come down with the power consumption on one hand. So because now in the pluggables, the power consumption is increasing more and more if the data rates increase, and so they consume too much power, they heat up too much. So how we can overcome this? And silicon photonics is one way to get really with the fiber directly to the ASIC. So combining then all the stuff into one ASIC to also having all the switch components also close by, and the optical communication will help there really to overcome this problem, right? So silicon photonics is on one hand good for the switch, but on the other hand is also good for coherent communication, because coherent will then get more condensed if you have a smaller packaging. And so it can move into pluggables, and if you can move coherent into pluggables, you have a much more data you can transfer over optical fiber than you can do in direct detection, and this will help a lot to solve the bottleneck problem.
Great. Well, anything that solves the bottleneck problem has got to be good for this industry. Yeah. Thank you for joining us.
Thank you.